RGB color transition. RGB LED can emit different colors by mixing the three basic colors, red, green, and blue. So it actually consists of three separate LEDs, red, green, and blue, packed in a single case. That's why it has 4 leads, one lead for each of the three colors, and one for the common cathode or anode, depending upon the RGB LED type. In this tutorial, we will be using a common anode type RGB LED. To produce other colors, you can combine the three colors in different intensities. Because the LEDs are very close to each other, our eyes see the result of the combination of colors, rather than the three colors individually. To adjust the intensity of each LED, you can use a PWM signal. To have an idea on how to combine the colors, take a look at the following chart. This is the simplest color mixing chart, but gives you an idea how it works, and how to produce different colors. This is the connection diagram of our project. The anode lead will be connected to the 5-volt pin of Arduino, using an orange wire. 3 other pins will be connected to the pin 9, 10, and 11 of Arduino, through 1 kilo ohm resistors. We will use PWM signal for simulating analog output, which will provide different voltage levels to the LEDs, so we can get the desired colors. We will connect the lead of red color, with pin number 11, green with pin number 10, and blue with pin number 9 of Arduino. This is the code of our project. First of all, we will define 3 integer type variables, red, green, and blue, void loop. This function continues to execute the code written inside it, over and over unless we reset the Arduino hardware board. We can see in the color band image, that there are lots of shades between these 3 colors, red, green, and blue. In our code, we will first illuminate the red color to its maximum intensity, then we will increase the intensity of green color using for loop. Blue LED will remain off. Now we set the intensity of green color to its maximum, and decrease the intensity of red color. By this way, we can generate all the colors between red and green. Now, we will generate the colors between green and blue. We will illuminate the green color to its maximum intensity, then we will increase the intensity of blue color using for loop. Red LED will remain off. Now we set the intensity of blue color to its maximum, and decrease the intensity of green color. By this way, we can generate all the colors between green and blue. Similarly, we will generate all the colors between blue and red. Now write this code on Arduino IDE compiler. Then save the program. Now check the code for any error, by pressing this check button. If code is correct, then upload it to the Arduino hardware board. For this, connect the Arduino board with laptop or computer using a USB cable. Now go to the Tools menu, and select Arduino Uno. Go to the port option, and select the port at which Arduino is connected. Then press this arrow button, to transfer the code to the Arduino hardware. Our code is now transferred to the Arduino successfully. Now, we will assemble our hardware. We will take 3 1 kilo ohm resistors, and RGB LED. This is a common anode type LED. Longest pin is of anode, and other 3 pins are for red, green, and blue color. We will cut the 3 pins and connect a 1 kilo ohm resistor with each of them. Now we will solder red, green, and blue wires with the resistors. Connect an orange wire with the anode pin. Cover the joints with insulation tape to avoid the shorting between the pins. Now we will connect it with our Arduino board. Connect the orange wire with 5-volt pin, red wire with pin number 11, green wire with pin number 10, and blue wire with pin number 9 of Arduino. Now we will power up our project and test its functionality. We can see that RGB LED is giving all the colors of a rainbow. We can change the speed of color transition by adjusting the delay inside the code. Our circuit is working perfectly. I hope you enjoyed the video and learned something from it. For any help or to clear your doubts regarding your project, you can contact us on our student care number 7007957715. To buy the items used in this project, you can visit our website www.erroltech.com. You can give us the orders on WhatsApp also. Thank you so much.